In question 1, we have to find the coefficient of x in the expansion of 2x minus 1 upon x to the power 5. Now we know that the expansion formula for a plus b to the power n is given by a to the power n plus nc1, a to the power n minus 1, b to the power 1 plus nc2, a to the power n minus 2, b to the power 2, and so on. Now we can apply the formula and expand it and look for the term in x, or we can directly try and figure out which of these terms will give us a term in x. Now, if I use this term, which is nc2, we can see that this will become 5c2. In place of a, we will put 2x to the power 5 minus 2 as n is 5, and b is minus 1 upon x to the power 2. 5c2 is 10. This will become 2x whole cube, so that will be 8x cube, and this will become 1 upon x squared. Simplifying, we'll get 80x, so the coefficient of x will be 80. In part 2, we have to find the coefficient of x in the expansion of 1 plus 3x squared multiplied by 2x minus 1 upon x. Now, when we have to find the coefficient of x, we are looking for terms that when they multiply, they will give us a term in x. So 1 plus 3x squared will remain as it is. Now we are looking for terms over here, which when they multiply by 3x squared and 1, they will give us a term in x. So from the previous part, we already know that one of the terms will be 80x. And now to find a term in 1 upon x, because if I multiply 3x squared by a term in 1 upon x, it will again give us the term in x. So in the numerator, we'll need a power 1 bigger than the power in the denominator. So we can apply the formula, which is NCR a to the power n minus r b to the power r. So we have to figure out what number to take in place of r. So let's say if I take 5c to the power of 2. So this will become a to the power n 5 minus 2. So this will become, all right, so we have already applied this to give us a term in x. So let's take 5c3 instead over here. So this will become 5c3. In place of a, we will have 2x to the power 5 minus 3. So this will be 2. And in place of b, I will have minus 1 upon x to the power 3. So 5c3 and this multiplied by, this will become 4x squared multiplied by minus 1 upon x cube. Now we can see that when I cancel x square and x cube out, this will give us a term in 1 upon x. Using our calculator, the value of 5c3 will be equals to, so 5c3 is equals to 10. So this will be 10 times 4 times minus 1. So this will become minus 40 upon x. Now multiplying 1 by 80x, we will get 80x. And multiplying 3x square by minus 40 upon x, we will get minus 120x. So 80x minus 120x will become 40 minus 40x. So the coefficient of x will be minus 40. In question 2, we have a point A that has coordinates minus 2 and 6. The equation of the perpendicular bisect of the line AB is given as 2y equals to 3x plus b. We have to find the equation of AB. Now let's say if we have a line AB, the perpendicular bisector will be passing exactly through the center of the line AB at an angle of 90 degrees. So we know that this angle will be 90. We have the coordinates of A as minus 2 and 6. Now to find the equation of the line AB, we need the gradient of the line, as we already have a point on the line which is minus 2 and 6. Now from the equation of the perpendicular bisector, we can rearrange it to write it as y equals to 3 upon 2x plus 5 upon 2. As the lines are perpendicular, so if this line has a gradient of 3 upon 2, the perpendicular line will have a gradient which is negative reciprocal or minus 2 upon 3. So now we have the gradient of the line AB, which is minus 2 upon 3, and we have a point on the line which is A minus 2 and 6. Applying the formula for equation of a line, y minus y1 is equals to m into x minus x1. The equation will be y minus 6 is equals to minus 2 upon 3 into x minus minus 2. So that will become x plus 2. Cross multiplying, this will become 3y minus 18 is equals to minus 2x minus 4. Bringing the 18 on this on the right hand side, the final equation will be 3y is equals to minus 2x minus 4 plus 18 will become plus 14. In part 2, we have to find the coordinates of B. Now, to find the coordinates of B, the first thing that we have to do is we have to figure out this midpoint. Once we have the midpoint, using the midpoint formula, we'll be able to find the coordinates of B. Now, this is the point of intersection of these two lines. We already have the equation of the perpendicular bisector, which is 2y is equals to 3x plus 5. And we have the equation of the line AB, which is 3y is equals to minus 2x plus 14. Now we can solve the simultaneous equation using a calculator. Even without a calculator, if we simply multiply this equation by 2 and multiply this equation by 3, this will become 4y is equals to 6x plus 10. And this will become 9y is equals to minus 6x plus 14 times 3 is 42. 6 and 6x will cancel, minus 6x will cancel. So this will become 13y is equals to 52. So y is equals to 4. Substituting y equals to 4 into any one of the two equations. So we'll get, let's use this first equation. So that will become 2 times 4, 8 is equals to 3x plus 5. So x will be is equals to 1. Now this 1 comma 4 is basically the midpoint of A and B. Now the midpoint formula is x for the midpoint is x1 plus x2 upon 2 comma y1 plus y2 upon 2. So we have the midpoint, which is 1 and 4. The A coordinate we already know is minus 2 and 6. So let's say A minus 2 and 6, we can label it as x1 and y1. And the coordinates of B, we can take it as x2 and y2. So we'll write it as minus 2 plus x2 upon 2, comma 6 plus y2 upon 2. To find each of these values, we'll compare 1 with minus 2 plus x2 upon 2. So this will become 2 is equals to minus 2 plus x2. So the x coordinate for B will be 4. And comparing 4 with 6 plus y2 upon 2. So that will become 8 is equals to 6 plus y2. So y2 will be equals to 2. So the coordinates of B will come out to be 4, comma 2. In question 3, we have to first prove the identity 1 upon cos minus tan whole square as 1 minus sine upon 1 plus sine. Now to prove the identity in AS level, we only use two of the identities that we know. One of them is sine square plus cos square equals to 1. And the other one is tan theta is equals to sine theta upon cos theta. Now instead of writing the whole thing, I will be using S, C, and T in place of sine, cos, and tan. So looking at this term, I can say that in place of tan, I can write it as, so this will be 1 upon cos minus sine upon cos whole squared, or I can just simply write it as 1 minus sine upon cos whole squared. So expanding 1 minus sine whole squared, that will become 1 minus 2 sine plus sine squared upon cos squared. As we need the whole thing in terms of sine, so in place of cos squared, I can write 1 minus sine squared. And if I look at the question, I need 1 minus sine in the numerator. So I will keep the 1 minus sine whole square as it is. And rather than expanding, I will try and simplify it with the denominator. Now factorizing the denominator, I know that 1 minus sine square will become 1 minus sine and 1 plus sine. And the 1 minus sine whole square will remain as it is. Cancelling 1 minus sine whole square with 1 minus sine, I will be left with 1 minus sine upon 1 plus sine, which was the identity that we had to prove. In part 2, we have to solve the equation 1 upon cos minus tan whole square is equals to 1 upon 2. Now we already have proven this as equals to 1 minus sine upon 1 plus sine. So we'll replace 1 upon cos minus tan with 1 minus sine upon 1 plus sine is equals to 1 upon 2. Cross multiplying, we'll get 2 minus 2 sine is equals to 1. So this is just 2. So this is 2 minus 2 sine is equals to 1 plus sine. Bring the negative 2 sine on this side, we'll get 1 is equals to 3 sine theta. So sine theta is equals to 1 upon 3. So theta will be equals to sine inverse of 1 upon 3. Now we know that sine is positive in the first and the second quadrant. So the basic angle that we'll get is, after doing sine inverse of 1 upon 3, this basic angle will be 19.5. So we'll make it in the quadrants where sine is positive. So this angle will also be 9.5, 19.5. So the two values of theta will be 19.5 and 180 minus 19.5. So theta will be equals to 19.5 and 180 minus 19.5, which is 160.5. In question 4, we have been given a triangle that shows a circle with radius r. The points A and B lie on the circle and ABCD is a rectangle. AOB is 2 theta and AD is the radius r centimeters. We have to express the area of the shaded region in terms of r and theta. The perimeter. So the perimeter of the shaded region includes the length AD, the length BC, the length CB, and the arc length AB. We already have the length of AD and BC as r. So we have these two lengths. To find the arc length AB, we'll apply the formula for arc length, which is S is equals to r theta. So multiplying r by theta, which in this case is 2 theta, the arc length will be 2r theta. To find the length of DC, we will first find the length of AB. So to find the length of AB, we'll apply the cosine rule. So AB squared will be equals to r squared plus r squared minus 2 times r cos of 2 theta. Simplifying this, it will become 2r squared minus 2r squared cos of 2 theta. Taking the square root on both the sides, so the length of AB will be given as 2r squared minus 2r squared cos of 2 theta. Now we can simplify this by taking r squared common. So when we take r squared common, this will become r squared into 2 minus 2 cos of 2 theta. So finally, the perimeter will be given as r, the length of AD, plus r, the length of BC. So this will become r plus the arc length, which was 2r theta, and the length of AB, which was so we can write the length of AB as, taking the square root of r, it can be given as r times square root of 2 minus 2 cos 2 theta. So we can write r multiplied by the square root of 2 minus 2 cos of 2 theta. And we can simplify the final answer by adding r and r. So this will become 2r plus 2r theta plus r times square root of 2 minus 2 cos of 2 theta. In part 2, we have been given that r is equals to 5 and theta is 1 upon 6 pi. We have to find the area of the shaded region. Now the area of the shaded, to find the area of the shaded region, first we'll find the area of the rectangle ABCD, and then we'll find the area of this part and subtract the two areas. Now to find the area of this part, first we'll find the total area of the sector and subtract the area of the triangle AOB. So to find the area of sector, we'll apply the formula half r squared theta. So area of sector will be given as half into r squared. So r squared is 5 squared into theta. In this case, theta is 2 theta. So this will be 2 into 1 upon 6 pi. Substituting these values in the calculator, the area of sector will be given as 13.1 centimeter squared. For the area of triangle AOB, we'll apply the formula half AB sine C. We know that the length of A and B is r, so this will become half into r squared into sine of theta. So this will be sine of 2 into 1 upon 6 pi. Substituting this value in the calculator, we'll get the area of the triangle as 10.8, and the units in this case, so there are no units, so we'll not include the units, but we give our unit as unit square. So this all will also be a unit squared. To find the area of the rectangle ABCD, we'll multiply the length R with the length of DC or AB, which was equals to R times square root of 2 minus 2 cos theta. So multiplying R by R times square root of 2 minus 2 cos 2 theta, we know that the value of R is 5 and the value of theta is 1 upon 6 pi. So this will be 2 minus 2 cos of 2 times 1 upon 6 pi. Substituting this value in the calculator, we'll get the area of the rectangle as 25 units squared. So we have the area of the rectangle, we have the area of the sector, and we have the area of the triangle. We'll subtract the area of the sector from the triangle to get the unshaded area. So subtracting 13.1 and 10.8, this will be equals to 2.3, and then subtracting it from the area of the rectangle. So the area of shaded region will be equals to 25 minus 2.3, which will be equals to 22.7 units squared. In question 5, we have a curve with the equation y equals to 3 plus 12 upon 2 minus x. We have to find the equation of the tangent to the curve where the curve crosses the x-axis. Now, to find the equation of the tangent, we need the gradient of the curve at the point where it crosses the x-axis. So to find the dy dx first, we'll bring the 2 minus x in the numerator. So differentiating 3, this will become a 0. Minus 1 times 12 will become minus 12 into 2 minus x to the power minus 2. And we also multiply by the derivative of 2 minus x, which is minus 1. So the negatives will cancel out, and the dy dx will be equals to 12 upon 2 minus x whole squared. Now, as we know, the curve is crossing the x-axis, we'll put the value of y is equals to 0. So substituting y equals to 0, we'll get 0 is equals to 3 plus 12 upon 2 minus x. Taking the 3 on the other side, this will become minus 3 is equals to 12 upon 2 minus x. Cross multiplying, we'll get minus 6 plus 3x is equals to 12. 3x equals to 18, and then x will be 18 upon 3, which is 6. Substituting 6x equals to 6 into the dy dx, we'll get 12 upon 2 minus 6 whole squared. So this will be 12 upon 4 squared, which is 16. So the gradient will be 3 upon 4. Now we know that the coordinates at the x-axis will be 6, 0. So using the equation of a line which is y minus y1 is equals to m into x minus x1. The value of y is 0 is equals to the gradient is, so this is 3 upon 4 into x minus 6. We can cross multiply and write the equation as 4y is equals to 3x minus 18. In part 2, it is saying that a point moves along the curve in such a way that the x coordinate is increasing at a constant rate. So x is increasing at a constant rate. It means that dx by dt is given as 0.04. We have to find the rate of change of the y coordinates. So we are looking to find dy dt, which is an unknown. The formula for the rate of change is dy by dt is equals to dy by dx multiplied by dx by dt. So the dy dx we already know is 12 upon 2 minus x whole squared. So to find dy by dx, we'll use 12 upon 2 minus x whole squared. The value of x is 4, so this will be 12 upon 2 minus 4 whole squared. This will become 12 upon 2 squared 4. So the dy dx will be 3. So multiplying dy dx 3 times the dx by dt, which is 0.04, the rate of change of y or dy dt will be is equals to 0.12. In question 6, we have a diagram that shows a straight line which is intersecting a curve at the points 1, 4 and 4, 1. We have to find the volume obtained when the shaded region is rotated through 360 degrees. Now, to find the volume of the shaded region, we can see that if we first find the volume under the line and then find the volume under the curve and subtract the two volumes, we'll be able to find the volume of the shaded region. So the formula for volume is pi multiplied by the integral of square of the function. And in this case, we'll apply the limits 4 and 1. So first we'll find the volume under the line. So volume under the line will be is equals to pi times the equation of the line. We can rearrange it to make it y equals to 5 minus x. So this will become 5 minus x whole squared, and the limits are 4 and 1. Integrating 5 minus x whole squared, you will get 5 minus x to the power 3 divided by the new power and multiplied by the derivative of the function 5 minus x. So the integral will become 5 minus x whole cubed divided by minus 3. Now applying the limits 4 and minus 1, we will get 5 minus 4 whole cube divided by 3 minus, now applying the lower limit 1, so we'll get 5 minus 1 whole cube upon minus 3. Substituting these values in the calculator, we'll get the volume of line as 21, and then we also add the pi to it, so the volume under the line will be 21 pi. Now to find the volume under the curve, first of all, we will whole square the equation of the curve. So the equation of the curve is y equals to 4 upon x. So we'll write 4 upon x whole squared and then apply the limits 4 and 1 and then add pi to the final answer. So this will become 16 upon x square, which can be written as 16 to the power minus 2. Integrating this, it will become 16 x to the power minus 1 divided by minus 1. We can write it as negative 16 upon x. Applying the limit 4 and 1, we will get negative 16 upon 4 minus 16 upon 1. So this will become minus 4 plus 16. So this will be 12, and we'll add pi to the final answer. Now we'll find the difference to find the volume under the shaded region. So the volume for the shaded region will be 21 pi minus 12 pi, which is equals to 9 pi. In question 7, part A, it says that the first two terms of an AP are 16 and 24. So A is equals to 16 and the second term is 24. As it is an AP, we can say that the difference will be, the common difference will be 24 minus 16, which is 8. We have to find the least number of terms of the progression which must be taken for their sum to exceed 20,000. So the sum formula for an AP is n upon 2 times 2a plus n minus 1 into d. So the sum must exceed 20,000. So we'll write 20,000, and as it must be greater than 20,000, so we'll write the sum must be greater than 20,000. So in place of n, we'll write n, a 16, so 2 times 16 will be 32, plus n minus 1 times 8. Cross multiplying, this will become 40,000 is less than, simplifying the bracket, will get 32 plus 8n minus 8. Expanding the bracket, this will become, so 32 minus 8 is positive 24, so this will be 24n plus 8n squared is greater than 40,000. Bringing the 40,000 on the right hand side, the equation will be 8n squared plus 24n minus 40,000 is greater than 0. Now we can make the equation simple by dividing the whole equation by 8. So this will become n squared plus 3n minus 5,000. Now using our calculators to solve this quadratic equation, the value of n will be 69.2. Now this value of n is basically the value which will make the sum 20,000. As we cannot have a term which is in decimal, so We have two options. Either we can take our answer as 69 and either take our answer as 70. Now at 69.2, the sum is 20,000, which means if we take 69, the sum will be less than 20,000. So we'll say that the number of terms must be at least be 70 so that the sum exceeds 20,000. In part B, we have a geometric progression which has a first term of 6 and a sum to infinity of 18. So A is equals to 6 and the sum to infinity is 18. A new geometric progression is formed by squaring each of the terms of the original progression. Find the sum to infinity of the new progression. Now, first of all, in the first progression, we know that the formula for sum to infinity is given by A upon 1 minus R. So the sum to infinity is 18. The first term is 6 upon 1 minus R. So we can first of all find the common ratio for the first progression. So cross multiplying will get 18 minus 18R equals to 6. So 18R will come out equals to 12. And then R is equals to 2 upon 3. Now it says that a new geometric progression is formed by squaring each of the terms of the original progression. We can assume that for the new progression, the first term will be the square of 6, which is 36. And this also means that the common ratio will be the square of the common ratio of the first progression. So in this case, the common ratio will be the square of 2 upon 3. So the common ratio will become 4 upon 9. Now to find the sum of infinity of the new progression, we'll apply the same formula, A upon 1 minus R. So this will be 36 divided by 1 minus 4 upon 9. We can substitute these values in the calculator, or we can simply take the LCM, and this will become 9 minus 4 upon 9. So this will become 36 times 9 upon 5. So the sum to infinity will come out to be equals to 64.8 for the new geometric progression. In question 9, we have a equation of a curve y equals to 8 root x minus 2x. We have to find the coordinates of the stationary point. Now, at the stationary point, the dy dx is equals to 0. So to find the dy dx of the equation, we know that y is equals to 8 root x. So we'll write it as 8x to the power 1 upon 2 minus 2x. Now differentiating 8x to the power half. So half times 8 is 4 x to the power. So subtracting 1 from half, this will become negative half, minus differentiating 2x, this will become 2. Putting it equals to 0, we'll get 0 is equals to 4, and then we can write it as upon root x minus 2. So this will become 4 upon root x is equals to 2, or root x is equals to 4 upon 2, which is equals to 2. Whole squaring both the sides, we will get the value of x is equals to 4. Once we get the value of x as 4, we'll substitute it into the equation of y is equals to 8 root x minus 2x. So this will become y is equals to 8 times root 4. So 8 to the 16 minus 2 times 4 is 8. So y is equals to 8. So the coordinates of the stationary point will be 4, 8. In part 2, it is asking us to find an expression for d square y upon dx square, or which also means that we differentiate the dy dx function again. Now we know that dy dx function was 4x to the power minus 1 upon 2 minus 2. Differentiating this again, we'll get d square y upon dx square. So minus half times 4 will be minus 2x, and minus half minus 1 will become minus 3 upon 2. Differentiating minus 2 will make it a 0. So the double derivative, or d square y upon dx square, will be minus 2 upon x to the power plus 3 upon 2. Now it is also asking us to determine the nature of the stationary point. So from the previous part, we have the x coordinate of the stationary point, which is 4. So substituting x is equals to 4 into this equation, we will get minus 2 upon 4 to the power 3 upon 2. So 4 to the power 3 upon 2 will be 2 cube. So root 4 is 2, 2 cube is 8. So minus 2 upon 8. As this is less than 0, we know that this will be a maximum point. So the nature will be a maximum. In part 3, it is asking us to find the values of x at which the line y equals to 6 meets the curve. Now the equation of the curve was y equals to 8 root x minus 2x, and the equation of a line is y equals to x. To find the values of x at which they intersect, we'll equate 8 root x minus 2x is equals to 6. Now to solve this equation, we must first recognize that this can be written as a quadratic equation if in place of x we write x as y squared, then square root of x will be written as y. So this will become 8y minus 2y squared is equals to 6. Rearranging this, we can write it as 2y squared minus 8y plus 6 equals to 0. Dividing the equation by 2, we'll get y squared minus 4y plus 3 equals to 0. Factorizing, we'll get y minus 3 and y minus 1 equals to 0. So the values of y are y equals to 3 and y equals to 1. As x was equals to y squared, so substituting y equals to 3, we'll get 3 squared. So one of the values of x is 9, and the other value of x will be, as y is 1, so 1 squared will be 1. So the two values of x are x equals to 9 and x equals to 1. In part 4, it is asking us to state the values of k for which the line y equals to k does not meet the curve. Now we know that the stationary point for the curve was at a point 4, 8, and it was a maximum point. To understand this, let's say if we have it on the x and the y axis, this is 4 and this is 8. So the curve's maximum point was at this y equals to 8. It means any line which is above 8 will not intersect the curve. So we'll say that for values of k greater than 8, the line y equals to k will not meet the curve. In question 10, we have a function f of x which is equals to 3 tan half x minus 2. In the first part, we have to solve the equation f of x plus 4 equals to 0. So f of x is 3 tan of half x minus 2 and then plus 4 equals to 0. Simplifying this, we'll get 3 tan of half x is equals to minus 2. We'll write it as tan of half x is equals to minus 2 upon 3. Now taking tan inverse of minus 2 upon 3, and we make sure our calculator is in radian mode as the domain of x is given in terms of pi. So taking tan inverse of negative 2 upon 3, we'll get negative half x is equals to minus 0.588. So x will be is equals to 2 times minus 0.588. So 2 times 0.588 will be is equals to 1.176. So this will be minus 1.176. As we have to give our answer to one decimal place, the final answer will be x is equals to negative 1.2. In part 2, we have to find an expression for f inverse of x. Now the method to find inverse of a function is, in first of all, in place of f of x, we'll write y. So we'll write y is equals to 3 tan half x minus 2. Now before finding the inverse, we'll replace y with x and x with y. So this will become 3 tan half y minus 2. Taking 2 on the other side, we'll get x plus 2, and dividing 3, we'll get x plus 2 upon 3 is equals to tan of half y. To make y the subject, we'll take tan inverse. So half y 1 upon 2y will be is equals to tan inverse of negative x plus 2 upon 3. And finally, y will be written as 2 tan inverse of x plus 2 upon 3. We can write this as f inverse of x is equals to 2 tan inverse of x plus 2 upon 3. Now we also have to find the domain of f inverse. So to find the domain of f inverse, we can find the range of f, which will be the domain of f inverse. And now looking at the function, which is 3 tan half x minus 2. So the maximum point of this curve will be at positive 1, as if we substitute 1 upon 2 pi into this function. So if I substitute 3 tan 1 upon 2 times 1 upon 2 pi minus 2. So tan of 1 upon 4 pi is 1. So 3 minus 2, the maximum value will be 1. And if I substitute tan of half into negative 1 upon 2 pi minus 2, so 3 times tan of 1 upon 4 pi will be minus 3 minus 2, so that will be minus 5. So as the range of the function f of x is from minus 5 to positive 1, the domain of f inverse will be given as x is greater than equals to minus 5 and less than equals to 1. In part 3, we have to sketch on the same diagram the graphs of y equals to f of x and y equals to f inverse of x. We know that f of x is 3 tan of half x minus 2, and the values of x are from minus 1 upon 2 pi till positive 1 upon 2 pi. Now, a simple way of sketching any trigonometric graph is to simply substitute the values of x and then finding the values of y and plotting them on the graph. So taking the value of x as minus 1 upon 2 pi. So if we substitute negative 1 upon 2 pi into this equation, so this will become tan of negative 1 upon 4 pi, which is minus 1. So this will be minus 3 minus 2, and this will be minus 5. So one of the coordinates will be negative 1 upon 2 pi, comma minus 5. Now, as negative 1 upon 2 pi is somewhere between negative 1 and negative 2, as the decimal value is negative 1.571. So this will be plotted over here, taking another value of x as 0. So tan of 0 is 0. So 0 minus 2 will be minus 2. So another coordinate will be 0, comma minus 2. And taking tan of 1 upon 2 pi. So if we take x equals to 1 upon 2 pi, so 1 upon 2 into 1 upon 2 pi will be 1 upon 4 pi. So tan of 1 upon 4 pi is 1, and 3 minus 2 will be is equals to 1. So the third coordinate will be 1 upon 2 pi, comma 1. So 1 upon 2 pi is 1.571 and 1. As this is the tan graph, this will be a curve of this shape. And now to draw the graph of f inverse of x, the first thing we know about f of x and f inverse of x is that they are a mirror image in the line y equals to x. So first of all, we'll make a line y equals to x in on our graph. And now to make the graph of f inverse, we can simply reverse the values of f of x. So if the value of f of x was minus 1 upon 2 pi and comma minus 5, for f inverse, the coordinates will reverse and they will become minus 5, comma minus 1 upon 2 pi. So minus 5, comma minus 1 upon 2 pi will be over here. 0 and minus 2 will become minus 2, comma 0. So this point will be over here. And 1 upon 2 pi, comma 1 will become 1, comma 1 upon 2 pi. So 1, comma 1 upon 2 pi will be over here. Once we have plotted the points, we will simply join them and we'll make a curve, and we'll make sure that it is specified that they look like a mirror image. So we can make this graph again to make sure that the graph that we have made do look like a mirror image of each other. So this will be the graph of f of x, and this will be the graph of f inverse of x. As it is a sketch, the values are not supposed to be very accurate, but they must be clear that they are mirror images of each other in the line y equals to x.